Chicken egg incubation technology and broiler raising methods have revolutionized the poultry industry, enabling efficient production of high-quality chicken meat to meet the growing global demand. In this video, we will explore the fascinating world of modern poultry farming, from the incubation of eggs to the processing of market-ready broilers. Let us begin with chicken egg incubation technology, a crucial aspect of the poultry industry that has seen significant advancements in recent years. Incubation is the process of maintaining optimal conditions for embryo development within the egg, essentially mimicking the natural process of a hen sitting on her eggs. Modern incubators are sophisticated machines designed to control temperature, humidity, and egg rotation with precision. The ideal temperature for chicken egg incubation is typically around 37.5 degrees C. This temperature must be maintained consistently throughout the incubation period, which lasts approximately 21 days for chicken eggs. Even small fluctuations in temperature can have significant impacts on hatch rates and chick health. Humidity control is another critical factor in successful incubation. The relative humidity should be maintained at around 50 to 60% for the first 18 days of incubation. This level of humidity prevents excessive moisture loss from the eggs in the last 3 days of incubation. The humidity is typically increased to around 70% to facilitate easier hatching. Egg rotation is a vital aspect of the incubation process that is often overlooked in nature. A hen will turn her eggs several times a day. Modern incubators mimic this behavior by gently turning the eggs at regular intervals, usually every 1 to 2 hours. This rotation prevents the embryo from sticking to the shell membrane and ensures even distribution of nutrients within the egg. Advanced incubators are equipped with automated systems that monitor and adjust these parameters continuously. They may also include features such as carbon dioxide sensors to ensure proper ventilation and ultraviolet lights for disinfection. Once the eggs have been successfully incubated and the chicks have hatched, we move on to the broiler raising process. Broilers are chickens raised specifically for meat production, and the raising method has been refined over decades to maximize efficiency and bird health. The broiler raising process begins immediately after hatching. The newly hatched chicks are transferred to a broiler house, which is a specially designed facility to care for young chicks. The brooder house is preheated to around 32 to 35 degrees C to ensure the chicks stay warm, as they cannot regulate their body temperature effectively in the first few weeks of life. The floor of the broiler house is covered with litter material, typically with shavings or rice hulls, which provides a comfortable surface for the chicks and absorbs waste. The house is equipped with feeders and water lines to ensure the chicks have constant access to food and water. As the chicks grow, the temperature in the house is gradually reduced, typically by about 3 degrees C each week, until it reaches around 21 degrees C. This gradual reduction helps the birds acclimate and develop their ability to regulate their own body temperature. Lighting is another crucial factor in broiler raising. In the first week, chicks are typically given 23 to 24 hours of light per day to encourage feeding and growth. As they age, the lighting period is gradually reduced to around 20 hours per day, with a period of darkness to allow for rest and to prevent issues like leg problems that can occur with constant light exposure. Nutrition plays a pivotal role in broiler raising. The feed provided to broilers is carefully formulated to meet their nutritional needs at different stages of growth. In the first few weeks, chicks are given a high-protein starter feed. As they grow, they transition to a grower feed and finally to a finisher feed in the last few weeks before processing. These feeds are designed to promote rapid growth while maintaining bird health. Modern broiler operations employs strict biosecurity measures to prevent the introduction and spread of diseases. This includes controlling access to the facilities using disinfectant foot baths and ensuring all equipment and vehicles entering the farm are properly sanitized. Regular health monitoring is essential in broiler raising. Farmers and veterinarians closely observe the birds for any signs of illness or distress. Vaccinations are typically administered to protect against common poultry diseases. The broiler raising period typically lasts between 6 to 8 weeks, depending on the desired market weight. During this time, the birds grow from about 50 grams at hatching to around 2.5 kilograms at market weight. This rapid growth is a result of selective breeding, optimized nutrition, and carefully controlled environmental conditions. Once the broilers reach the target weight, they are transported to the processing factory. The processing of broilers into market-ready chicken products is a complex operation that involves multiple stages. Upon arrival at the processing plant, the birds are typically held in a quiet, dimly lit area to reduce stress. They are then hung upside down on a moving line that carries them through the various stages of processing. The first stage is stunning, which renders the birds unconscious to ensure humane treatment. This is typically done using an electrical water bath or controlled atmosphere stunning. Following stunning, the birds are quickly bled to ensure rapid and complete blood loss. Next, the birds enter a scalding tank filled with hot water. This loosens the feathers for easier removal. The feathers are then removed by a series of rotating rubber fingers in a process called plucking. After plucking, the carcasses go through an evisceration process where the internal organs are removed. This is a critical step that requires careful attention to avoid contamination of the meat. The carcasses are then thoroughly washed and chilled to prevent bacterial growth. Following chilling, the carcasses may be cut into parts or left whole depending on market demands. They are then packaged, labeled, and prepared for distribution to retailers or further processing facilities. Throughout the entire process, strict hygiene and quality control measures are implemented. This includes regular cleaning and sanitization of equipment, temperature monitoring of products, and microbiological testing to ensure food safety. The poultry industry has seen significant technological advancements in recent years. These innovations have improved efficiency, animal welfare, and product quality. For instance, the development of in vivo vaccination technology allows for the vaccination of embryos while still in the egg, reducing stress on hatched chicks and improving overall flock health. Another notable advancement is the use of robotics and artificial intelligence in processing plants. These technologies can perform tasks such as cutting and deboning with high precision, improving yield and reducing labor costs in broiler houses. Advanced environmental control systems use sensors and automated equipment to maintain optimal condition, as some systems can even predict and prevent potential issues before they occur based on data analysis and machine learning algorithms. Despite these advancements, the broiler industry faces several challenges and considerations. One of the primary concerns is the environmental impact of large-scale poultry operations. The industry is working on developing more sustainable practices, including better waste management systems and the use of alternative feed ingredients to reduce reliance on resource-intensive crops. Animal welfare is another important consideration. While modern broiler raising methods have significantly improved bird health and growth rates, there are ongoing discussions about the ethical implications of rapid growth and high-density housing. Many producers are exploring ways to balance efficiency with enhanced animal welfare practices. The use of antibiotics and poultry production has also come under scrutiny due to concerns about antibiotic resistance. As a result, many producers are moving towards antibiotic-free production methods, relying instead on improved biosecurity vaccination programs and the use of probiotics to maintain bird health. Looking to the future, the poultry industry is likely to see continued technological advancements. We may see further integration of artificial intelligence and big data analytics to optimize every aspect of production, from egg incubation to processing. There is also growing interest in alternative protein sources, including plant-based and cultured meat products, which may impact the traditional Broiler industry sustainability will likely be a key focus, with efforts to reduce the carbon footprint of poultry production, improve water usage efficiency, and develop more environmentally friendly packaging solutions. We may also see advancements in genetic technologies aimed at producing birds that are more resistant to diseases, more efficient at converting feed to meat, and better adapted to diverse environmental conditions. In conclusion, chicken egg incubation technology and broiler raising methods have come a long way, transforming poultry production into a highly efficient and technologically advanced industry. From precisely controlled incubators to automated processing plants, every step of the process has been optimized to ensure high-quality, safe, and affordable chicken meat for consumers worldwide. As we move forward, the industry will continue to evolve, balancing the demands for increased production with considerations for sustainability, animal welfare, and changing consumer preferences. The future of poultry farming promises to be an exciting blend of traditional animal husbandry and cutting-edge technology working together to feed a growing global population.